and algebra general. His area of expertise is the theory of fuzzy automata based on the different lattice structures by using the tool from algebra, topology, category theory, and fuzzy transformer. So today Dr. S. P. Tiwari is going to talk about the fuzzy automata based on the residuate lattice, a mathematical perspective. So I am very glad that he is live from the there. So now without the wasting of too much time, I would like to invite Dr. S. P. Tiwari sir. So welcome sir.
Sir,
Am I
yes, sir. You are audible, sir.
okay? So, what about my screen? Are you able to see the screen?
Yes sir. Yeah, visual sir.
I think is it means it is okay.
Yes sir. Is it okay sir?
Okay. So, thank you, Vivek, Mahesh, Anand, everyone for inviting me and organizing this e-conference. First thing, sorry for joining late, and even I cut the timing, but still I will try to means discuss on some points. This is as per the topic. I am. This is fuzzy automata based on receipt weighted lattice, a mathematical perspective. So the idea is first thing fuzzy automata. Whenever we are talking about automata, we are going to theoretical computer science. When we are discussing about receipt-weighted lattices, we are discussing lattice structures. And from mathematical perspective, whenever we are studying, we have already studied a number of concepts from mathematics, starting from algebra to topology, and all these concepts play an important role. In the study of automata theory, this has already been shown. But there are some new concepts. There are some new concepts which also which are also useful to study fuzzy automata, and these theories are not available in general mathematics, which we have studied either in algebra or in topology. So first thing I will show distributed lattices. Second thing we will come on fuzzy automata.
Sir,
Lastly, we will.
please share your site sir.
I have already shared my slide.
No sir. Click on the share. Click on the
I think
share
I
but so not visible.
okay. Just a minute.
So showing as the arrow of.
Yes, Vivek, arrow up or arrow down?
Yes sir. Click on the arrow above and click on the PPT sir. Open slide.
Is it okay?
Uh, yes sir. Visible sir.
Okay. So first we will start from some concept from residuated lattices. Second, we will come on fuzzy automata, and we will not go in detail, but little bit we will discuss what is mathematical perspective here. And that is in the sense of topology, and this is not mentioned here, but this is the work done by one of my research scholar, Mr. Sailen Singh. So there were a number of lecture on fuzzy sets, and you have already studied. I think most of the speakers have already discuss about fuzzy set. So as usual, we always say that okay, fuzzy set is a map from x to closed interval 0, 1. And what is the interpretation of lambda in terms of at a point x? That is some membership value. I think most of the audience are now aware about this concept. And obviously, when lambda is coming to the set 2.01, we say that okay, this is we are talking about ordinary crisp subsets of x. So this is the basic theory of fuzzy sets, which was introduced by Jate, and well-known theory, and most of the people are working on it. But right now, researchers has moved from this domain, that is 0, 1, and a number of lattice aspects are also available, and this 0, 1 turned out to be a particular case of that. So what people are using right now, there are more general structures, just like Gödel algebra, MB algebra are well known as Lukasiewicz logic, product algebra or product logic. Similarly, BL algebra, which is actually basic fuzzy logic, Hating algebra, that is actually intuitionistic logic, complete residuated lattice, that is based on residuated logic, and which is our interest right now, on which we are going to discuss. And finally, one more concept is there, the people who are working on quantum logic, they are using as complete orthomodular lattices. So these are 7 things mentioned here, and my emphasis is on only point number 6. And the interesting point about 6 is that actually the first 5 are particular cases of this 6th one. So whenever we are studying on complete residuated lattices, or whenever we are going for a theory based on residuated logic, actually we can capture first 5 things. So the important about only this thing. Now, this is the well-known definition of residuated lattice. When we are coming to this one, and residuated lattice is nothing but an algebra. This algebra is, there are 7 symbols are here, especially this L with 6 new things, where the first 5 things, if we are looking for L, infimum, supremum, and 2.01, this would be a bounded lattice. With obviously, whenever we are talking about bounded lattice, there should be smallest and greatest element. So its smallest element is 0 and the greatest element is 1. Commutative monoid structure is here, that is, this one is a binary operation on L, and with the greatest element, this is a commutative monoid. And when we are coming to this one, and this is actually called residuation, this property is known as residuation. And the thing is that what is the relationship between this multiplication as well as this arrow? So the relationship between this multiplication and arrow is this one: A multiplication B is less than or equal to C, if and only if A is less than or equal to B arrow C. And this is called an adjoint pair. And why this is called residuation? Why this is residuated lattice? Actually, this is term is coming from category theory, and this property is known as residuation property. So one thing is from there, but this is nothing but a lattice structure. Just see, well known from discrete mathematics, we are always aware that we have a lattice structure plus 2 new things are here, and these 2 new things make this as a residuation, and that's why this is called a residuated lattice. So important feature with this one is only this property. And complete meaning is that lattice is complete, and one property is written here. This is right cancellative property. Right cancellative property meaning is that we are using with this x and x, they get cancelled out, and finally we are getting this y. Why there are left cancellative, a number of properties of there. But why only I writing here right cancellative? Because only this property is useful for the work which I am describing here. And this is multiplication and residuum. One of the important thing is that whenever we are moving from residuated lattice, so how to define the complement of point in L, and that is nothing but x arrow 0. Arrow is known that, note that this arrow is nothing but residuum. Arrow is nothing but residuum. So these are pair of adjoint pairs. There are different one. For example, whenever we are going for Lukasiewicz logic, so minimum supremum is already there. If we are taking closed interval 0, 1, so smallest element is 0, greatest element is 1. How to define this multiplication and residuum? That is defined in this way. That is defined in this way. That is x multiplication y is maximum of x plus y minus 1, 0, and x arrow y is minimum of 1 minus x plus y and 1. This Lukasiewicz algebra is famous, and this is already available in most of the book. And complement is nothing but 1 minus x. So this is for Lukasiewicz algebra. If we are coming to the product algebra is given in this way, where multiplication is given like x multiplication y in this closed interval 0, 1. Now this implication is given like this one. Complement will be here. Complement is here. And this is important. Whenever the people study the theory of fuzzy sets, there is a general question that how fuzzy set is differing from crisp set theory. What extra we are going to achieve what type of mathematics we are studying, and by studying such of mathematics, what new things we can get. Answer is yes, we are getting a number of new things, and new things is whenever we are going for residuated lattices. Interestingly, this property is not available in our crisp set theory. This property is not available in crisp set theory. That complement of complement is not the same thing. So actually, this makes a lot of difference in fuzzy set theory. Similarly, another one is that is Gödel algebra. In Gödel algebra, multiplication is defined in terms of minimum. This residuum is defined in this fashion, while complement is defined in this way. And interestingly, whenever we are looking again, this is complement of complement. Again, this is not equal. So these two things at least we have seen, whether we are talking about product algebra or Gödel algebra. In these two algebras, at least this property is not going to hold. So what new things we are going to do here? First thing is this concept is known as factorization of fuzzy sets. And why L fuzzy sets? Because our interest here is only for residuated lattices. So to make a difference from ordinary fuzzy set to residuated lattice, just we are using L fuzzy set instead of writing simple fuzzy sets. So a natural thing will come whenever we are defining general fuzzy set. We are saying that okay, its codomain is nothing but 0, 1. This is the basic definition when we are defining, and we are saying that this is codomain 0, 1. Now what we are going to do is that we are going to replace this 0, 1 by a general lattice. So if we are going to replace a general lattice, so natural question will come. What example you are providing? You are still providing all the example when you are taking L equal to 0, 1. Whether we are talking about Lukasevich algebra, product algebra, or Gödel algebra. In all the cases, everything is same. Can you tell me that is there exist any lattice, residuated lattice, which differ from 0, 1 and can be discussed on it? Answer is yes, you can do it. You can do it. And how to do it? The idea is this thing. First, let us define some operations. Define some operations. Let us take a non-empty set X and take any two fuzzy sets. And these two fuzzy sets, if residuated lattice is known to us, this operation is known, and now define star the new product as in this way, and this is some arrow with this one and this is with this one. These two are defined in terms of residuation operation, that is implication, and this is defined in terms of what is the original multiplication. And if this is happening, this is the new concept, factorization. Factor, note this name of factor we already well known. Why we are defining when we are taking anything X and we are saying that Y and Z are its factor. So we are saying that X equal to Y into Z. But here is different thing we are using. We are using this less than or equal to sign is using because this is lattice structure, and in lattice structure this partial order relation is defined in terms of this type of things, that is less than. That's why we are using not equal to, we are using less than or equal to. If anyone is going to take this as equal, obviously that will be general factorization what one studies. So let us take any this star what is defined above, and if this is happening, then this pair AB is called factorization of C. This is a simple example. Let us take set of natural number. Let us take two fuzzy set and let us take Cn. Then this becomes a factorization of this thing. Now, interesting thing is what question I raised to you, that whether instead of 0, 1 can we construct some residuated lattice. Answer is here. Take any L and take Lx, that is collection of all fuzzy sets. Even if you are taking L equal to 0, 1, so take all fuzzy sets from X to 0, 1, that is the simple one. And interesting fact is that with this one, this is a commutative monoid and this is a complete residuated lattice. So we can construct a complete residuated lattice which is fully free from this 0, 1. This is collection of all maps from X to L. And what is the definition of this A arrow, this new arrow B? That is defined in this way. Again, an example is given here. So this residuated lattice theory is fully based on mathematics. This is another thing. Here we talk about factorization of a fuzzy set. that is C. But if we are going to talk about the factorization of the collection of fuzzy set, is it possible? Can we do it? Answer is yes. Just like if we are going to talk about factorization of a set, that is collection of all fuzzy sets from X. So there, this is nothing but this is the pair of maps F1 and G1 such that two conditions satisfied. Two conditions satisfied. Question is why this type of conditions you are taking. So again, the thing is that factorization, this is nothing but this is providing the idea of factorization. And second one, why we are going to from 0 to 1 only, because so that B should not get 0 and B should not always get that yes equal to 0. Interesting fact is that if you are going to take G1 as a constant map and that constant map sending everything to 1, so obviously G1 0 will always be 1. And let us take F1 as identity map. So you are getting yes to yes. That is the natural example here. So if you are going to take F1 as identity map and G1 as a constant map sending everything as 1, a natural example is always present here. These are some features that how F1 is connected to G1, how G1 can be expressed in terms of F1. This is the interesting relationship between G1 and F1 because this residuum property is available here. This is an example. I am not going to explain this complicated things, but this is the way how one can do it. How one can do it. But the idea is only you have to find out two functions, F1 and G1. This is the thing. This is again one of the interesting results which I am going to discuss here. That let us take if you are having two factorization, and by using these factorization, if you are defining a map, and this is nothing but this is a map from Fs to Fs to L, and Fs is collection of all fuzzy subsets of S defined here. If we are defining in this way, note that we are getting a fuzzy partial order relation. We can also get a fuzzy partial order relation. So by using this theory of factorization, one can also induce a partial order relation. So this is first part. This is first part of this one, that this how this residuated lattice can be introduced, what is its theory, and how factorizations can be introduced by using residuated lattices. Full of mathematics and fun of mathematics is here. Now coming to automaton theory. When we are coming to automaton theory, question is why we are discussing about fuzzy automata. Automaton is always available. And even the graduate students, computer science graduate students are always studying it. This is well-known course in the name of automata theory of theoretical computer science, where they are studying automaton. But why the need of fuzzy automaton? First thing. Second thing, if we are going to fuzzy automaton, what new things we are going to get? What new mathematical structure from mathematics of point? Which things are interesting? Now come to this thing. Whenever we are coming to dispenser machine, we can get everywhere, and this is the time to get use dispenser machine. In COVID times, don't touch anyone, just use machine. So what the thing is that we are going to insert coin, and when we are going to insert coin, we are getting the requirement things, whether we are going to use some gold rings or water bottle, we are getting the things. But if there is some problem in machine, what will happen? Coin will be returned to you. And if this is dispensing you, obviously window will be closed. So this is we can say that this is a model of automaton. What is going on? There are these circles. These are called states. Circles are called states. Now, what are inputs? Inputs are insert coin, coin return, open window, and closed window. These are the internal thing. So whenever we are inserting coin, what will happen? We are moving from start to we are going to ready to dispense. And if everything is okay here, then window will be open and that will dispense. So actually this is called a transition function. From start state, we are moving from one state to other state. And start state, or this is also known as initial state, and dispensing, this is also a final state that we are getting the things. Even one can also assume this as a final state. So this is a diagram, but this diagram is what this diagram is representing. This diagram is representing a mathematical model for a machine, and automaton is well known mathematical model of machine. That is the well-known simplest mathematical model of machine. That is an automata. Now, if we are discussing on this picture, let us say that obviously whenever we are inserting the coin in machine, there is some internal structure which read the coin, that whether this is the coin of 5 rupee, this is the coin of 10 rupee. The thing is that, for example, today government is going to launch a coin of 50 rupee, and if we are going to that dispenser machine, obviously that dispenser machine cannot recognize that coin. Even 50 is mentioned there, that dispenser machine is recognizing a rupees of 55 note, but that cannot recognize a 50 rupees coin, but that is recognized 5. Everything that is recognized 5, that is recognizing 0 can recognizing, but 50 cannot be recognized. So thing is that can be internally designed it that if 50 is coming, so machine itself design, and after that machine is thinking and machine is doing the same job with this one. So whether this type of machine is possible, answer is what should be mathematical model of such machine. Answer is go with fuzzy automaton. Go with fuzzy automaton. That should read 5. That should read 0. There should be something like algorithm there so that 50 can be recognized and the machine should work in this way. So actually this is the need of fuzzy automaton here. So why we are going to fuzzy automaton? We are going to model a modern machine. This is the answer. So mathematically a lengthy type of things is here. This is written because we are not writing only 0 1, we are writing the general things. So this is a 5 tuple. This q, what I told you, that is a state. This is for input. This is the transition function, meaning is that if you are going to input something, if you are in some particular state and making input of something, where to get, this is the initial state, this is the concept of final state. So the thing is there, this T is defined in terms of this map, and this map is from sigma to L power Q cross Q. That is, if we are making an input of input A, so we are going to get a fuzzy set Q cross Q to L. So what will be the structure, how to move from this some state in Q to some state in Q? This is the whole idea. Initial states may also be fuzzy. We can start from anywhere. This is not necessary that this particular state will be fixed. Similarly, final state can also be fuzzy. Any state may be final. Fuzziness coming in the picture. So if anything is fixed, that is, if IQ is greater than 0 for anything, we are saying that, okay, this is initial. Similarly, for final, when we are defining here, I means we are saying that Q is our non-empty set. Q is non-empty set of states. But we are not saying that finite or infinite. But note that whenever we are discussing in real life, we always think about finite things. We always think about finite thing. Even whenever we are going to design a machine, we are saying that number of states should be finite. But from mathematical point of view, finite is not much more important. Mathematics says that, okay, whenever we are going to take infinite things, we can draw a better picture. So here we have taken, when we have defined it, this is a general state, whether this is finite or infinite. But if that is finite, then we can say that, okay, this is the finite state. This is an extension, and the person who are familiar with automaton, they can see that this sigma star, mathematically this is monoid, and in the language of computer science, this is the collection of strings. So this is not necessary that we are reading word by word. We can read a string. So how to read a string? This is the mathematical explanation of this thing. So mathematical explanation is given here. And the first thing is that this is empty string. Empty string means you are not providing anything. So if P is equal to Q, the value is 1. Obviously, if you are not changing state, so this value should be 1. And if you are not providing anything and you are changing the state, this should be 0. And how to go for a string, this is the idea. Uh, these are the things. Whenever we are looking, there may be some absurd states. We are not going to use some of the states. A number of states which we are not using, obviously that is not useful to do that one. So the thing is that what is the meaning of this is called complete. Complete meaning is that if you are making some input, obviously transition should hold. This is the idea. And deterministic meaning is that transition should be through unique path. Mathematically this is written, but meaning is transition should always be through a unique path. And this is crisp. Crisp meaning is what you have already studied, that when our codomain is fixed as 2-point set. This is the meaning of crisp. Whenever we talk about fuzzy automata, so there should be some language. Language is always assigned with automaton. So this is the meaning that whenever any string is given, we have to start from initial, take a transition, go to final thing. So take the combination of all these, you will get a fuzzy language. And equivalent fuzzy language meaning is that, equivalent fuzzy automata meaning is that if they are accepting the same thing, obviously one can design it. For example, for this purpose, one can design two different machines. And if two different machines are doing the same job, they are equivalent. This is the meaning of this definition. Some people also try to study some smaller structure, that is go from initial to transition only, don't go to final, or start from transition, go to final only. So these are some reduced structures of fuzzy languages. These two things are reduced structures of fuzzy languages, and they can also be used. Now come to the main concept. How mathematical perspective is coming here, that is how we are using factorization here. So the thing is that if you are starting from a fuzzy automaton, we can construct a factorization here, that is fix some particular yes, and now define a factorization. This is collection of all the factorizations like this one, that is AIBI, where FIGI is a factorization of LQ. So we have already seen that how to factorize L power x. So begin with factorization of LQ, that is Q is our set of state. And after that, let us take Fs like this one. Now change the transition function, and now transition function is not from L power Q cross Q. This is from Fs cross Fs. And here I'm not going in deep because I don't have much time. So these things, these structures can be defined as a multiplication. This is from residuation lattice. So transition, initial and final, these three things are defined. State set we are going to change, that is we are using factorization. There is no change in input, and rest three things are defined here. So we can construct another fuzzy automaton. And this is an example of that. Now what is the beauty of this fuzzy automaton, that similar things, how this extension can be done on strings. This is the idea. This lemma is providing the structure that how TS behaves on strings. Interesting thing is the next one. If you are going to take factorized automaton, then what is the behavior on all the strings except empty? Two things, two languages can be expressed again here in terms of this factorization. And this is the important thing. And finally, this is the result. That if we are going to take a fuzzy automaton, take corresponding factorized L fuzzy automaton, then this corresponding factorized fuzzy automaton is equivalent to the same thing. Factorized fuzzy automaton is equivalent to the same thing. So this is important point here, that when we are going to use factorization, and we are constructing in the fuzzy automaton, still in the sense of acceptance of language, we are getting the same thing. That is not going to change. Language will be same. One may ask the question here, if the language accepting language is same, why we are going to construct a new automaton? Why you are going to construct a new automaton, and why you are using such lengthy theory of factorization, residuated lattice, and so on? Answer is again here. Answer is one, the known theory in automata is that is the well-known theorem is there, that is Myhill-Nerode theorem. And what is the importance of that theorem? That theorem says that how that theorem provides a path that how to construct a minimal automaton. Minimal meaning is that, for example, for a work, you already have an automaton, a machine with 100 states. So can you construct a machine which is having 5 states, 10 states, or minimal in number? Minimal in number, that is, you cannot reduce that. So even we can do the same job with only 10 states machine. So can you do it? Answer is Mahil-Nerod theorem there. Mahil-Nerod theorem is also available for fuzzy automaton, and one can also minimize by using this thing. But this concept of factorization, this is also providing a beautiful lecture, this beautiful path that whenever you are going to use this factorized fuzzy automaton, whenever you are going to use this factorized fuzzy automaton, that will be minimal, and this is the result. But the question is, be careful in choosing the lattice. Lattice should be right cancellative. Important point is that this will not hold for all lattices. Your lattice should be right cancellative. So why we are using this factorization theory here? Answer is simple. This is not only to construct a fuzzy automaton corresponding to a given fuzzy automaton which is doing same job. No. First thing, yes, in a point that the motive is same, that one means the constructed automaton will accept the same language, same fuzzy language, but that should also be minimal in nature. That will always have a smallest number of states, and you cannot construct any fuzzy automaton smaller than this. So this is the use of factorization and receive-weighted lattice automaton. This is a new theory associated with fuzzy automaton, which is not available in automata theory, because automata theory is not enriched by using the concept of receive-weighted lattices. So this is one of the part which I want to discuss. This is example. There is topological characterization also. Yes, Mahesh.
Hello. Yes, sir. Verification.
Mahesh,
Hello. Sir, बुला रहे हैं?
Yes, sir. Yes,
I
sir.
think I want to stop here. I do not want to continue.
Okay, sir. No, sir.
There are a number of things, but I do not want to continue. And why I do not want to continue? I think you people are aware about that.
Yes, sir. Aware, sir.
Yes, sir. Okay.
So the
Okay,
next
sir,
thing,
no problem.
if any person requires topological flavor, I can share the slides. They can study it. But right now I will close. I will not continue it.
Okay.
Okay, sir.
Yes, please.
Thank you. Thank you, sir, for your nice presentation and valuable talk on the such interesting topic. So now it's over to Dr. Mahesh Dubey to introduce our second speaker.
इनकी तबीयत ज़्यादा खराब है यार, मैं वही तो कह रहा था।
Any question from the audience?
No, Dr. Mahesh, please introduce the second.
Thank you, Dr. Vivek. Now allow me to introduce our distinguished speakers, Dr. Kavi Kumar Jacob. Dr. Kavi Kumar Jacob obtained his MSc in 1999 and PhD in 2005 from Annamalai University, India. He started his career as a senior lecturer in mathematics at Vellore Institute of Technology, India in 2004. And since 2006, he has been associated with Department of Mathematics and Statistics, Faculty of Science, Technology and Human Development, University Tun Hussein or Malaysia. Currently, he is Associate Professor in the Department of Mathematics and Statistics, University Tun Hussein or Malaysia. His research interest includes bipolar quantum logic gates, mathematical modeling by delay differential equations, algebraic structures, especially semi-groups and semi-rings, automata theory, neutoscopic graph theory, and algorithms. He is author of more than 80 research publications in international reputed journals, So far, he has supervised 3 PhD students. He is a holder of several scientific grants of Ministry of Higher Education, Malaysia and University Tun Hussein Malaysia since 2008. He is also a member in several professional bodies such as American Mathematical Society and Society for Industrial and Applied Mathematics. And he also a reviewer of reputed journals as Computer and Mathematics with Applications, Journal of Applied Logic, Bulletin of Malaysia Mathematical Societies, Iranian Journal of Fauji System. Dr.
Actually,
Kumar,
good afternoon, everyone.
Dr. Kumar
Dr. Magi, I
yes, sir.
think the introduction, I think the is enough effort my introduction.
Yes, sir.
Okay,
Finish me.
just begin.
Allow me to finish this.
Yeah, okay.
Sir.
Okay.
So, and Dr. Kumar is also recipient of various awards like Ramanujam Centennial Awards out for Pro Chancellor Dr. M.A.M. Ramaswamy Endowment for Meritorious Student in Mathematics, Best Researchers Award in Mathematics given by University Tun Hussein in Malaysia in 2012, and Excellent Service Award for Outstanding Performance given by University Tun Hussein in Malaysia in 2019. Now, without further delay, I would like to hand over the session to Dr. Kavi Kumar, sir. Welcome, sir.
So good afternoon, everyone. This is Kavi Kumar Jacob from Malaysia. I'm currently I'm working as the associate professor in University Tun Hussein in Malaysia, one of the government university in Malaysia. Okay, today actually, and first of all, I thanks the organizer to invite me to give you this opportunity. And my next thanks to my beloved professor, Dr. S.P. Tiwari. Actually, he makes me easy about my presentation. Actually, he given all the information about what is fuzzy and fuzzy automata and the application and the model of mathematical model of automata. So I think I no need to explain more about the fuzzy automata. So okay, now I'm going to share my slides. Dr. Magesh, can see my slides? Hello?
It is not visible, sir.
Sorry?
It is not visible, sir.
Can't view. Sorry.
So click on the arrow above.
Okay, now you can see my screen.
Yes, sir. Visible, sir.
You can see my slides.
Yes, sir.
Okay. So dear participants, today my talk about introduction to
It is not clear visible, sir. I think.
not clear visible. About now, it's okay.
No, sir. I think you are using, I think, mobile phone.
Yeah, yes.
Can you, sir, give me your slide on mail? I share here in full mode and you just explain one by
Yeah,
one.
yes. Can.
Because it is not clear visible.
Okay, 1 minute. I will share now. Magesh, I already share my slides to you. Magesh, did you receive my slides?
Mahesh, please unmute yourself.
Okay. Sir, when you send in my Gmail account or Outlook?
By WhatsApp.
Sorry, sir. Okay, sir, no problem.
Now you see Magesh the way. No,
It is visible, sir.
sorry,
Now it is visible. Very good.
it's clear.
Yeah,
Yeah, sir.
clear.
Now it is clear, sir.
Okay, can start now.
Yes.
Okay. So today my topic is introduction to neutoscopic automata theory. Actually, before we enter into the neutoscopic automata theory, I could like to introduce some of the fuzzy extensions, some fuzzy extension sets, especially interval valued fuzzy set, indeterministic fuzzy set, and bipolar fuzzy set. And finally, I want to tell about the neutoscopic set. Actually, everyone know what is fuzzy logic and the fuzzy sets. Fuzzy logic is very useful tool to handle the any uncertain situations or vague concepts. So the fuzzy set we use the closed interval 0, 1 to represent the membership value, because we used to assign membership value for any element in our fuzzy set from the interval 0, 1. So instead of actually 0, 1, actually in the fuzzy set, our membership value, we use a single element, single membership value. Instead of a single membership value, when we use interval, some interval from membership value 0 to 1, then we call the fuzzy set is a interval valued fuzzy set. So one of the extension of a fuzzy set. The definition of the interval valued fuzzy set actually, um, A is a fuzzy subset. Then we have a element X. Then that element X has lower limit membership value and upper limit membership value, because the membership value in between a pool of intervals. Likewise, the indeterministic fuzzy set. Indeterministic fuzzy set is one of the very useful extension of a fuzzy set, which is introduced by Professor Atnosov in the indeterministic fuzzy set. Actually, the indeterministic fuzzy set is actually is represent it is represent the membership degrees, that a pair of membership degree and non-membership degree. So it means that actually the indeterministic fuzzy set are useful to represent express in the uncertainty in assigning membership degrees to any elements. Because the definition of indeterministic fuzzy sets also, element has two membership value, one membership degree, another one is a non-membership degree. And these are the operation of indeterministic fuzzy set. And next, another extension of bipolar fuzzy set is we have seen in fuzzy set, interval valued fuzzy set, and indeterministic fuzzy set is all talking about the truth value of our given set. But when we talk about our real world problems, our real world problem is always balanced, easily balanced. Actually, so far the other extensions, intrinsic fuzzy set, interval fuzzy set, only talking about the truth value of our given problems. But when it comes to something, the opposite side, opposite means talking about the complementary. The complementary is actually we in a probability we used to tell the complement for the complement of 0 is 1 and the complement of 1 is actually 0. But in reality that is not true actually, because the reality equilibrium means if the complementary of 1 is actually -1, means the other side, means the contrary part. When we talk about the bipolar fuzzy set, we represent the membership value. We talking about actually. We, we concern about actually in the bipolar fuzzy set, we concern about the irrelevant elements and the contradictory properties. As a contradictory property means whenever we have some truth value, we have opposite value is a negative value. So in a bipolar fuzzy set, we extend our interval 0,1 is the value of 0,1 is extend to -1 to 1. Actually, here we can divide. We can subdivide the interval into 3 parts. The one is membership degree is belongs to the open interval 0 to 1, which we call actually the elements. The membership value is for elements somewhat satisfy our given property. For the another one, only the membership value is something 0. The elements are irrelevant to our corresponding property. And the other one is the negative one from the -1 1 to 0, which the elements is somewhat satisfy the implicit counter property, means the opposite negative property. So later I will give some example to understand the extension, these kind of extension of fuzzy sets. So actually in the bipolar set, we have 2 type of fuzzy set. One is representation, another one is canonical. But most of the research is based on the canonical representation. So the canonical representation, actually the membership value for any element in our set is only one for the positive value, another for the negative value. So in the fuzzy set, in the bipolar fuzzy set, we have 3 type of situation we have. Suppose the membership value, the positive membership value is not equal to 0, which means the element has the positive membership value, and the negative membership value is equal to 0, means is somewhat satisfy the our given property. And another one is the positive, and the negative positive value is 0, and the negative value is equal to is not equal to 0, which means that the membership have some negative membership value. Then we can say that the membership that element has somewhat satisfied the counter property. And if both membership value is not equal to 0, means this we call the overlap property. Actually, in the intrinsic fuzzy set, we have membership value and non-membership value. When we talk about the membership value is actually mapping from 0 to 1, and the non-membership value is 1, and the complement actually 1,0. Then we have one hesitation part. The hesitation part we called actually indeterminacy from the intrinsic fuzzy set. The indeterminacy is actually depends on the combination of the membership value and the non-membership value. That is actually the hesitation part. Usually they denote by pi of x. That pi of x equal to the formula for the pi of x is 1 minus of summation the addition of membership and non-membership value. So actually here in the intrinsic fuzzy set, the hesitation part or the indeterminacy part is actually very certain, because the value of the indeterminacy is based on is depends on the membership and non-membership value, but the membership value, non-membership values are uncertain, but the indeterminacy value is very certain, is because it depends on the membership and non-membership value. So now I could like to compare these the extension. The first one is interval valued fuzzy set and the intrinsic fuzzy set. actually is almost is same actually, because when we instead of because in the interval value set we have a lower value and the upper value. Actually, the lower value we can take it as a positive value, the means the membership value of the individualistic, and the negative the upper value we can take it as a complement of the our non-membership value of the individualistic. When we come back, then we will have almost same kind of operation of the interval value fuzzy set having almost the intrinsic fuzzy set basic operation operators. So the conclusion is actually interval valued fuzzy set and the intrinsic fuzzy set have the same expressive power and the same set of operations. Because the intrinsic fuzzy set representation is useful when there are some uncertainties in assigning membership degrees. So when we compare the intrinsic fuzzy set and the bipolar fuzzy set, the positive value, because in the bipolar value we have two type of membership value, one from the positive side, another from the negative side. The positive side, if we can compare to we can compare to the membership value of the individualistic, and the negative value we can take as a negative of the non-membership value. So actually here the mu of a p of x is actually positive membership value which satisfy our given property, and mu of a the membership degree which satisfy the property of our individualistic property. Same as the negative side is satisfy the counter property, and the other side is satisfy the non-property. Actually, in the bipolar, the negative value is satisfied something implicit counter property, means the anti property, but in the individualistic we actually is not counter property, but it is not a property actually. That is the difference of bipolar and individualistic fuzzy set. So the both bipolar fuzzy set and individualistic fuzzy set are actually apparently it's look like same, but both are different, actually a different extension of fuzzy sets, because the counter property is not usually equivalent to the non-property of A. So we can see this this statement by using some example. Here I want to show some example, the example of frog prey, actually frog prey. Here I choose some elements. Mosquito is a prey for the frog, and dragonfly is another food of the frog, and turtle is considered is a one of the food of the frog, and the snake is the another prey. But when we assign some membership value by using interval value fuzzy set, mosquito is the most favorite food of the frog. So we assign the membership value for lower and upper is same, so means 1, because the mosquito is the most favored food of the frog. That's why we assign membership value for lower and upper is 1, and the dragonfly is somewhat is not most favorite, but somewhat is interested food. So the membership value, the lower limit is 0.4, the upper limit is 0.7, and the turtle, actually the turtle is not a food of the frog. So it's something actually is irrelevant. So but when we assign membership value by using interval value, actually is just 0, 0, because we are not considered turtle is one of the food of the frog. So we assign just 0. And snake is also, actually snake is not irrelevant, but actually is the opposite actually. But when we use interval value set, the membership value for the snake, because it's the membership value for the frog's prey. So the membership value of the snake is also 0, 0. And when we come to the intrinsic fuzzy set, the same one actually for the mosquito is the most favorite, but is 1, and the non-membership or non-grade is actually 0. It means the complement, actually the 1 and the complement is 0, and dragon is 0.4 and 0.3, and turtle is not relevant to the frog. So we assign the membership value is 0, but non-membership value is actually 1. Snake is also same, 0 and 1. And when we using bipolar to assign membership value for frog spray. Mosquito is a favorite, so positive value is 1, and the negative, the means the opposite is actually 0. And dragonfly 0.4 and 0. And when we say, here comes the turtle is the irrelevant. So because of the irrelevant, we assign the membership value 0, 0, because it's not, the turtle is not a food of the frog's prey. So we just consider the turtle is one of the species, but is not a food of the frog, so we assign membership value 0. But when it comes to snake is actually not a food of the frog, so we assign positive membership value 0. But the counter property means the other side property means the equilibrium. The equilibrium means the other side is actually -1, because frog is the food of snake. So that is the counter property actually. That's why we assign membership value -1. Okay, so far we have seen what are the extension of fuzzy sets. Now we come to the nutroscopic set. Actually, nutroscopic set is the one of the new extension in from the fuzzy set, which is introduced by Florent and Samarande. So actually, the nutroscopic sets come up with some idea of opposite and the neutral, because other extensions only consider either the opposite or the indeterminacies. But here, both opposite, in nutroscopic set, both opposites also uncertainty and the neutral also uncertainty. In the intrinsic fuzzy set, actually intrinsic fuzzy set, the indeterminacy is not uncertainty, but is certain. But in the nutroscopic, the beautiful idea behind the nutroscopic set is actually the neutral is also uncertain. Because, for example, when we two persons fighting each others, if someone because two of them fighting each other, which means that both are opposite parties, they are fighting for their own rights. So both of them have their own membership value. One in the positive, another one is the negative, maybe opposite membership values. But when police arrive in the scene, or if any peacemakers, when they come and compromise or peace making, that also actually means that is we call is a neutral. Actually, the policeman or someone is a neutral person comes and make a peace. That's also actually not certain, is uncertain. So this kind of situation is considered by which means the neutral and the opposite actions. The combination of this concept we call actually nutroscopic set. So here A is the actually property, and non-A means actually the other than the A, not a property actually, which is equal to actually a non-empty set actually according to the because something began in the neutral. So actually the common part of uncommon things. So it is true in some restricted case, because most of the investigations consider only the dynamics of opposite interactions actually. So either the property of A or the anti-property of A only, but not studied by the neutral one. That's why the nutroscopy is become one of the extension of a fuzzy set. So in our in our everyday life, we are not only interact with the opposite thing, because even the opposite things are uncertain, and neutrals also is inevitable sometimes. So that is we call is a neutral A. So combination of all these three, we can say this is this concept we call as a nutroscopic set. So here I'm given some characterization of a nutroscopic set. The first one is the property of A is which is we call actually truth membership function, and the opposite one means opposite two opposite A and anti-A is two opposite things. The anti-A is actually opposite of A, which is we called actually it's wrong. Actually, it is called actually false membership function, and the neutral A we call is indeterminacy membership function. The one thing actually here, because the neutroscope is quite different from indeterministic, because already mentioned indeterministic determinacy is a certain membership value, but in the neutroscopic is uncertain. Membership values are uncertain actually. So the neutroscopic logic introduces a percentage of indeterminacy. So due to unexpected parameters hidden in some proportions. So actually the truth membership value we call is T, and the indeterminacy we mention I, and the false membership value we denote by F. Okay, this is the definition of actually neutroscopic set. For an element having 3 membership value, so truth, indeterminacy, and false, all membership values we assign from the interval 0,1, as already our Dr. Tiwari mentioned about the residual lattices. So far, none of the research done by any other researchers by using residual lattice in the neutroscopic set. So if anyone interested, they can start work and can publish papers by using residual lattice in neutroscopic automata theory actually. So here all the membership value, if the summation of all membership values is in between 0 to 3. So already Dr. Tiwari mentioned about the fuzzy automata, the mathematical model of fuzzy automata. I ignore all these slides and I go to the definition of fuzzy automata. Actually, fuzzy automata is a triple actually which consists of some members. So that is Q is a finite set of states, and some sigma is the finite set of input symbols, and R is the initial state. Z is the set of output symbols. And the most important thing in automata is the transition, actually the transition from one state with the input to the next state. So when we do some transitions, each input having some membership value, based on the membership value, we can assign membership value for the next state. Actually, actually the research, most of the research in fuzzy automata to minimize the number of state in the given automata. So and as well as we need to enhance the transition of our fuzzy automata. And here omega is the output symbols from our once we done the transition, we will have we will reach the next state. The next state will produce some output. So the output we write in Z. That is denote the set of output is we denote by Z. And in the neutroscopic automata, actually in the neutroscopic automata so far, only 4 papers are available in the literature. So in the first paper was published by Tahir and Khan in the African, I think African Mathematics Journal, in the title of Interval Neutroscopic Finite Switchboard State Machine. And other papers are also published by Tahir in 2018. In that paper, he used single-valued neutroscopic finite state machine, actually like a fuzzy set, single-valued fuzzy set. So the single-valued neutroscopic logic he used in finite state machine and the finite switchboard state machine also. And myself, I published one paper in 2019 by using the concept of general of fuzzy automata. That is one of the different concept, because most of the fuzzy automata they will consider only the when we face the overlapping membership value, we consider we take the maximum value only, but by using general fuzzy method, we can precisely choose which membership values choose for the next state actually. So because in other most of the methods they consider only the transition input membership value only, but in the general fuzzy automata is consider both input and the previous state membership value also. And one more paper published in 2020 by in the title of distinguishability and the inverse of nutroscopic finite automata. So in the nutroscopic automata, almost the definition is same as fuzzy automata. The only difference is actually the final state and is the input, the output, the transition, everything is same. Actually, here the transition we have three type of transition. One for the truth membership value, another for the indeterminacy, another for the false membership value. Here, actually, okay. Actually, the transition is consists of three type of transition: the false, indeterminacy, and state. So almost here, the definition here the value is almost the false and the indeterminacies almost look like same. Actually, see here the delta 2 qi with the empty set to qj. The membership value is 0 if qi equal to qj, and 1 if our qi is not equal to qj, which means not reach the same state, but transit to the another state. The membership values maybe belongs to some 0 to 1. And the delta 3 is for the false membership value, membership function. It's look like almost same because the value is 0 if qi equal to qj and 1 equal to qi is not equal to qj, which means that the two equation is looks like same, but when we have a real world problem, the values, the membership values are actually uncertainty. It's based on depends on the problems actually. So because we are looking for the indeterminacy, actually the indeterminacy is uncertainty. So that's why is entirely different from the intrinsic fuzzy set. So this is for the if the number of inputs increase, then you will have the same type of equations actually. Supremum of delta 1 q1 comma x1 to r, then the delta 1 r x2 to qj, and there's the indeterminacy and the false also looks like same, but I already as I mentioned earlier, is all depends on the problem, because here the indeterminacy also have uncertainty membership value. And this is for the nutroscopic automata. In the automata, we have the output function. The output function also is almost like say fuzzy automata, but here we have three type of equation, which is belongs to the truth, indeterminacy, and the false membership functions. So I want to stop now. So actually, this is the just I thought to give only the introduction of fuzzy automata. Okay, actually, I stopped my presentation because from this presentation, actually, I want to give a small idea to the participant of what is actually nutroscopic automata, because the nutroscopic automata is a current research actually, because most of the researchers, they are doing the research in fuzzy automata and other type of automata, but the nutroscopic fuzzy automata still is open to everyone to have to write a good papers and can publish in a good journals. So if any question you can ask.
Thank you very much, sir, for your nice presentations and the valuable talk on such interesting topics. So now I open this section to the audience for question and discussions. Anyone? Yeah, Dr. Vinay Gautam, sir.
Yeah, yes.
Yeah, very good afternoon, sir. Uh, as you have discussed with the nitrostopic stat, and you all already discussed membership in 0 to 1. So my question is that when we use lattices, resuscitated lattices instead of 0, 1, the condition with nitrostopic set, that is T plus I plus F, is lying between 0 to 3.
Yeah.
It will be change or not?
You mean the 0 to 3 can change or not, right?
Yeah.
Okay.
When we are taking lattice, other type of
Can change.
resuscitated.
Is all depends on what interval you, what algebraic structure you are taking. It's all based on the algebraic structures.
Okay.
Because restricted lattice is one of the algebraic structure to enhance the membership of our sets.
Okay. Basically, we are taking in resuscitated lattice L equal to 0 to 1, and then take our lattices.
Yeah.
So in
Yes.
that case,
Hello.
And
hello.
yes, yes. From the audience, the Neha Singh asked,
Okay.
can we apply the residue lattice in the bipolar fuzzy set?
Yeah, I have no idea. Actually, so far I never tried. But I have seen one paper in the Journal of Symmetry.
Yes, sir.
They used in algebra, actually semi-group.
Okay, sir.
Yeah, yes.
And from the live section, ask the question: can this type of study be carried out by the ordinary fuzzy sets instead of lattice?
Sorry.
Can this type of study be carried out by the ordinary fuzzy sets instead of
Yeah.
lattice?
Yeah. Yes. Can.
Okay, sir. And the
Okay.
last,
Actually, okay. The previous question. Okay. And now I remember one paper written by Horry, Horry, bipolar fuzzy automata by using restricted lattices.
yes, sir. Yes, please
General
discuss it, sir.
bipolar. Yeah. Yes.
Okay, sir. So another question is from the live section, Palas Datta. There is another theory called the picture fuzzy set.
Okay.
Could you please explain the difference between the uh, picture fuzzy sets and the what?
Neutrosofic.
And
Okay.
neutrosopic?
Okay.
That's
I
it.
have no idea about picture fuzzy set.
Okay,
Because
sir.
there are many extensions. Okay, I'm concentrating on only nutroscopic, bipolar, and fuzzy set. Even I'm not concentrating indonestic fuzzy set.
Okay, sir.
Yeah.
So any good book for the resident lattice, sir? Any?
I think so far no books actually available for restricted lattices, but many good papers are available in available in the literature actually. I think you can Dr. Irina papers. She used restricted lattice rightly in her paper. If you Google her paper, maybe you can understand the concept of the restricted lattices.
Okay, sir. Once again, sir, thank you, sir,
Uh,
for taking the time from your busy schedules and deliver a lecture in our workshop. So
As-
now,
yeah,
yes, sir.
yeah. Tell me.
So now, after the 5 days of glorious scientific tour, family, we have reached to the valedictory section of this online workshop on new trend in the fuzzy and rough set theory and applications. I, Dr. Vivek Singh, on the behalf of Manipal University, Jaipur, welcome you all to the part of this prestigious closing ceremony. So now do we begin with the formal closing ceremony. Today we have with us Professor Kalpana Sharma, Head Department of Mathematics, Statistics, Manipal University, Jaipur. We were fortunate enough to become the host of this online workshop on new trend in the fuzzy and rough set theory and application. We made it possible under the leadership of Professor Kalpana Sharma, member works of the advisory committee. So now, let me now request Professor Kalpana, head of the department mathematics and statistics, uh, kindly say the detail about this workshop. Welcome, ma'am.
Thank you very much, Dr. Vivek. A very good afternoon to all the dignitaries present, the speakers who have spared their time, valuable time for this workshop, and dear participants. It's my pleasure to welcome you all in this workshop, and I feel that this workshop must be very, very useful for all of you. And we are honored by the presence of all the speakers who have spared time for this workshop. And I want to tell you that we have closed the registration and everything. Still, we were getting continuous calls and the messages from many of the people across India and outside India for the registration process. So I just want to share with you that there were more than 650 registration received from 21 different countries, including India, USA, Czech Republic, Latvia, Iran, Egypt, Malaysia, Spain, Indonesia. So list is very long, and we are fortunate enough to serve all of those people. Out of these 650 registrations, we have actually bifurcated into two parts. So 250 candidates we have allowed to join in the MS team, and rest of the candidate we have given them the live link so that they can take the benefit of this workshop. And we have tried that all the queries of the participants can be solved with the interaction of all the speakers. So we are thankful to all our speakers who have spared their time and then tried to solve all the queries raised by the participants. And we all are feeling very honored that these many participants were there, so which imply the success of this workshop. So I am conveying my thanks to all the organizing members who have taken those efforts and made this event a successful one. Thank you very much, Dr. Mahesh, who has taken the lead, and Professor Pratap, who have joined this thing to help them and to uh, do all the kind of necessary efforts, as well as Dr. Vivek and Dr. Ashok, Dr. Rishikesh, who has worked day and night for making the event a good one. And I just want to share that sometimes we feel that the participants who join, if they don't find a lecture very much beneficial, sometimes they may not be attending the full one. But the organizing team needs to be there for the full day. So they all spared their Saturdays, Sundays for making this event happen in a smooth, less manner. So thank you very much to all of them. And of course, without the speakers, we cannot have the success of the this kind of workshop. So all the speakers, they have agreed on our invitation and spared their time. So I am thankful to all of them. Now I'm just giving one suggestion. In this pandemic situation, we all know that these kind of events, sometimes people feel that it's easy to conduct, but that is not so. So they have worked very hard, but output needs to come out of this workshop. So I think this is made a very big group. who are interested in this particular topic. So my appeal to all the participants, all the speakers, that please be connected, and then we can form a research group which can work together, because we all know that collaboration sometimes can bring out a good kind of research. So since you all are connected with each other, so my appeal is that try to form a group and then try to have some good research projects, good research publications, something like that. Patent you may think of. So this kind of thing should come out as an output of all these kind of workshop, which we are learning through this workshop. So then this kind of thing will be I should say successful. Yes, event goes very well. The you may have learned many of the things, but implementation part is still left. So my appeal, my request to all the participants, to all the speakers, that they should come together, they should work together and come out something which will be beneficial for the society, for our own country, and for across all the people who are there. In this pandemic situation, we need to work together, and we should come out with the things which can help all of us. So once again, I thank you, all of you, for making this event a big success. Thank you very much. Over to Dr. Vivek.
Thank you very much, ma'am, for sharing the concluding remarks about the workshop. So now I'd like to request to all delegates and the students present there to come up with their views and experience. Anyone can present their views and experience?
Yeah, yes, sir. So this is Parvati from Tamil Nadu.
Yes,
Yeah,
ma'am.
actually we had each and every session is very useful, and of course very helpful for updation, and I got few points which can be taken for my research scholars. So really thankful to all of you for the organizing team. That too, with this situation, have done yeah, good job, very good job. Thanks a lot. Thanks to the
Thank you,
team.
ma'am. Thank you, ma'am.
Thank you.
Sir, this is Dr. Devnath Bhattacharya.
Yes, sir.
Already I spoke on Sunday. So what Madam told, you people always busy in Saturday, Sunday also. Anyway, we are also attended full time, and
Yes, sir.
at least 3 lectures I marked were very well and very resourceful. And it is a great achievement for the university, your university, that to
Yes.
conduct this kind of workshop. We are really happy to take part of this workshop. Thank you very much.
Thank you very much, sir. So anyone? Another? From the audience? Any students who want to present their view and experience? Okay. Now invite Dr. Anand Pratap Singh to give the vote of thanks. Welcome, sir.
Thank you, Vivek. Honorable professors, our most valued invited speakers, dear participants, ladies and gentlemen. I deem it a great privilege to have been asked to extend a vote of thanks on this occasion. I, on behalf of Department of Mathematics and Statistics, Manipal University, Jaipur, and on my own behalf, convey my deep regards and hearty thanks to the speakers of today's session, Dr. S.P. Tiwari and Dr. Kavi Kumar Jacob, for gracing this ceremony and sharing with us their rich experience on fuzzy automata. We are greatly encouraged by their gracious presence and immensely benefited by the inspiring lectures. Dear friends, we have today with us Head Department of Maths and Statistics, Manipal University, Jaipur, Professor Kalpana Sharma. I wish to express our generous thanks for giving encouragement by his gracious presence. I would like to express our profound gratitude to the Dean, Faculty of Science, Professor Anup Kumar Mukhopadhyay, Director, School of Basic Sciences, Professor Lalita Ledwani, Head, Department of Mathematics and Statistics, Professor Kalpana Sharma, for providing encouragement and supporting Minutely to organize this event. Without this support, it won't have been possible for us to organize this workshop. My sincere thanks to Dr. Mahesh, Dr. Ashok, Dr. Vivek, and Dr. Rishikesh of Manipal University, Jaipur for their constant support in organization of this workshop. I take this opportunity to extend our most sincere thanks to all the participants from India and abroad. I am really thankful that they joined us and I hope that they will be benefited from this workshop. I am also very grateful to the technical team of Manipal University Jaipur for smoothly organizing and making this event a great success. Once again, I thank all of you for your cordial cooperation. Thank you so much.
Thank you, sir. So now announce that the e-certificate will be provided within 1 week. So you can, if not provided, you can write us in this case certificate have not reached you within the specific time. So thank you everyone, and the feedback link provided on the mail and as well as in the chat box, also on the group. So thank you everyone. Hmm.